I was hired at Purdue through nanotechnology engineering, and I was looking at applying nanotechnology and related technologies to problems in biological engineering. In my lab, we develop biosensors, which are devices that can detect biological molecules and produce a signal that can easily be read. We use them as diagnostic devices, for example, in animal health applications, in human health applications, and food safety applications. One specific example would be bovine respiratory disease, which is a big problem. It causes losses of almost $1 billion every year, and we have a project to try to tackle and improve the treatment of cattle suffering from bovine respiratory disease. So right now, if you want to understand something very well, you need to send samples to the lab, do everything in the lab. We are trying to build tools that will give you same type of results, but out in the field. We are very diverse in the problems we tackle. For example, just within my lab, although we develop biosensors, we do it for many different applications, ranging from plant health to animal health to human health. One of the unique things about the research that we do is that we started with the problem from the end user. So we started learning more about the stakeholders and what they're dealing with day to day before we come up with solutions. Often as engineers, we have solutions and we try to find problems. But being at Purdue, especially at Ag and Biological Engineering, I've been able to find that working with stakeholders is much easier, and that helps us translate the technologies better.
So my research program is exploring microbial ecology in a lot of different environments. I come from a variety of backgrounds. So first I was a civil engineer, then an environmental engineer, then a microbiologist during my PhD. So I came to biological engineering through a little bit of a roundabout way, but I think that background has made my research program stronger in that I can collaborate with a lot of different people with different backgrounds. So a lot of my applications are in drinking water right now, but I've also explored well water, for example, which is really relevant for the rural communities around here, and controlled environment agriculture. I hope to find ways to prevent pathogen growth and encourage the growth of good microbes. A lot of the microbes that grow in these systems aren't harmful at all, so I'm looking for ways to encourage the growth of the ones that aren't harmful and prevent the growth of the ones that are harmful. I'm hoping to learn how to sustainably use microbes to do things that we want them to do. So to increase safety and prevent pathogen growth without using harmful chemicals.